master support in I2C. Have you gone through anyone the concept? Hello.
Hello, ma'am.
Yeah, tell.
Yeah, it supports multi-master, but point is that it can communicate one at a time, not all the together.
Okay. So how can we communicate anyone? Suppose here there are multi masters and multiple slaves. Master 1 is a microcontroller 1 and master 2 is a microcontroller 2. There are two microcontrollers and there are four number of slaves, whatever the sensors or ROM memory or some temperature gyrometer, whatever. So there are four number of slaves. Okay. Now both masters need to communicate with all the slaves. Okay, even there are four number of masters or five number of masters. In I2C protocol, both masters cannot communicate at a time. Okay, so one by one only possible. We need to write the arbitration concept here. So how can we do that? Multi-master in the sense two microcontrollers or any two masters, whatever. Both cannot be communicate at a time. Both cannot run the bus. Bus in the sense we need to transfer the data through bus only, right? So both bus are not active at a time. Only one bus will be active. So how can we give the priority? Suppose two masters are competing here. So for which master we can give the bus first?
The masters which will transmit the lowest address
Okay.
of the dominant bit, that will continue first.
Okay, so here the arbitration concept is needed. Okay, so whenever multiple masters trying to send data at same time, bus will conflict. Conflict will be occurred, right? So arbitration ensure that only one master win the control of the bus without any corruption of data. Okay, so that's concept is nothing but arbitration. We can use any arbitration, but mostly here we connect the pull-up resistors, right? So we use the AND operation for these masters. Okay, so how arbitration will be worked step by step? Suppose first of all we have the start condition, right? In address we have the frame format, we have the start condition. So all masters monitor the bus before sending the start condition. Okay, so if the bus is free, suppose I'm going through the frame format, so here there is a start condition. Start condition is nothing but SDA must be high to low, nothing but negative edge. Okay, we'll consider as a negative edge of the clock or negative edge of SDA. Okay, SCL will be constantly high. So this is what the start condition. So first all the masters monitor the bus before sending the start condition. If the bus is free, then it will be sending the start condition. If the bus is free. Okay. Next, address or write read bit transmission. How this address will be transmitted? All competing masters, whether there are two masters or four masters, whatever, all competing masters start the transmitting address plus write or read bit at same time. Okay. Now, in this case, whatever the open drain logic is there here, I2C. Okay, now I2C uses open drain logic. The devices pull lines low but not drive at high. Yesterday we discussed why we should pull low, we should not pull high, right? So here the devices can pull the lines to low. Okay, so each master monitor the SDA line. while transmitting the bits. It will be monitoring the SDA line. Main is the SDA line, right? Now bit by bit arbitration will be happen. How bit by bit? We are taking the address, right? The particular address. So each bit will be considered. So on for every clock pulse, the master check if the value of SDA line matches what it is sending. Suppose master A address having 10 1000000 7-bit size. Master B having 101 0 double 100. Suppose. So every bit by bit it will be checking, and if both match, then it will be considered till there, and without whatever the match bit is there, it will either lose the bus or win the bus. Okay, so how it will be happen? So first of all, if master send a 1 bit, it sees 0. Okay, if there is a 0, it loses the arbitration and stop transmitting. If it just I will show you the example here. So suppose here master 1 address, master 2 address. Okay, 1 1 0 0 1 1 0 0 1 0 0 0. Till here it is a common. Next one M1 0 M2 1. So here M1 is sending 0, M2 will be sent 1. So M2 will realize and it will lose the arbitration. M1 will continue the transaction. Okay, like that. M1 will lose wherever we have 1. It will lose the bus. Wherever we have 0, it will be lost the, it will have the bus. Why? Because here we are doing AND operation. AND operation in the sense the highest support will be 0 only. Okay, that's why whatever we got 0, not 1, whatever we got 0, it will won the bus. Wherever we got 1, it will lose the bus. Okay, remember, if a master sent 1 but it sees 0, okay, it lose the arbitration, and also it stop the transmitting. Only one master will be continued. The master will continuously sees whatever the bits are there. Okay, if no match, then the bus will win. It will stop immediately, and either one master lose the bus, one master won the bus. Okay, suppose the same example we have 1010000, and next bus having 1010100. Okay, till where both are match, till here both are match. 1 2 3 4. Okay, next bit master A is sending 0, master B is sending 1. Okay, so this line reads 0. Master B will lose the arbitration. 0 into 1, 0. Okay, so this 0 is equal to here. The master B will lose the bus, and through the master 1 we can send the data. This is what AND operation. If you see yesterday note, whatever notes I have shared, in that also we have taken some example. So by doing the AND operation, okay, whichever lost the bus, then remaining master will transmit the data with in the bus. Okay, Clear? Everyone understood? So what is the real time usage in the sense application? Here clearly the picture is there, right? So whenever the both like there are two masters, microcontroller or sensor, okay, with another slaves like EPROM or display. In this case, whenever the masters need to initiate the transfer, we use the arbitration concept. Okay, clear?
No, ma'am. Hello.
No?
No.
Yeah, tell.
So, uh, this the arbitration is like I see if I have a sensor, I have two masters which both will be sending the slave address. Correct.
Okay.
Okay. So how we because masters will only have that particular lane which will be
Okay,
controlled
I
by processor.
understood. Suppose here we have three slaves. Slave 1, slave 2, slave 3, slave 4. Suppose 7-bit address it need to send. 4 slaves means what is the address if you start from zeros 0, 0, 0, 0 and
No, in between different slaves will have different address. Consider if I need to access the gyrometer, one of the slave means I have two masters. Both masters can access the gyrometer, correct? Which will having a common address, correct?
okay.
So how in this master side for the particular gyrometer the slave address is common, correct? In between the two masters, both needs to access one particular slave. The read address or write address will be common, correct?
Hmm.
So how we will prioritize between the masters is that is meant by arbitration.
So here there are 4 slaves addresses. This is what it is sending some address. Okay. From here onwards, it will be checking one by one bit common. First, these all bits common. Okay. Next, it will be going to all bits common. Okay. Next, it will be going to all bits common. Okay. Next, it will be going to all bits common. And here it will be checking. What is the end operation for all these bits? Here, 1 is there. Here, 0. End operation is 0 here. Okay.
Okay.
Now, this will lose the bus. Okay. This 4 will be getting the bus. Now this 4 will be computed each other with a different address. Okay. And then it will be moving to second. This 4 will get compute and within these 4 any one will be selected. Again and or NAND operation we need to write and one bus will be selected. So in first transmission, one will be selected, and in second transition, these two, suppose again output is 0, suppose these two will lose the bus, and now these whatever zeros are there, those 3 will get in a competition. So in that 3, again we need to do the arbitration. Now using OR operation or AND operation, we can do. Okay. So based on that, each bit by bit, we will check and send the data. Like that, if not, there are 3 different addresses. So here, 1, 0, 1, 00, 00, 1, 0, 00. So in this, which one will continue and which one will lose the bus? First of all, in first bit, it will be checking to all the 3 bits. All the 3 bits are high and SDA will be high. So ABC will continue. 3 buses will continue. Okay. And then it will be checking 0. All ones means what is the SDA? End operation between all 1. All zeros means end operation between all zeros 0. So 3 buses will continue. Again AND operation between all ones, 1 only. So again 3 will be continued. And again AND operation between all zeros will be 0. Again ABC. Suppose if you take ABC, all will be continued. Now 0, 1, 1. 0, 1, 1 means AND operation between 0, 1, 1 will be 0. In this case, only A will be continued. Remaining 1, 1 will lose the bus. Now, in the sixth one, this B and C, whatever B, C is there, between these two only we will get the competition. Okay. Now, again do the AND operation 0, 1. Now, what is the output? 0. Now, C will lose the bus and B will won the bus. B will do the operation. B will continue with the bus. Remaining what is left? C is left. So with the C, we need to do the last final one will be the C. So first A, next B, next C, like that. Did you understood?
Yeah, I understood how the selection between the slaves are made, but my query is like, consider if I have like I need to access I have only one slave and I have two masters. Okay, only one slave.
You can we can send the data to that slave. No need to. Okay, two masters, one slave.
Then
Okay.
there will be a competition between the two masters, right? At what time?
Why
At what point?
there will be no competition? See, suppose this master 0 address and this address is 1. We do 1 into 0. 1 into 0 means output is 0. Obviously, this master will win the bus and this one will reject.
No, but
Ma'am,
the
the
address.
master with all bit 0, he will always get the bus because 0 multiplied with anything 0 and 0 will every time win. Then how the master with 1 bit will win?
Because leftover is that only, right? Whatever, see, here also leftover is C. C have 1 in this example, but leftover is C. Whatever the leftover is there, that will get the bus in final stage.
Thing is that I think we can. There's a concept called so-called clock stretching, right? Which
Yes,
will
clock
pause
stretch.
the communication of one master, and it will, I think, complete the communication with another master, and then by making the SCL line low, I think by that also it can happen.
Clock stretching concept is like different frequencies. Whenever the master is working at one frequency and slave is working at some other frequency, master just it will hold the data. That means temporarily it put 0 so that we can make the device whole, just passing the communication temporarily so that we can achieve the correct frequency. That's what clock stretching concept. Just slow down the master using the clock stretch. Automatically we make it a 0 and do the transmission. Forcefully we are making it 0. Suppose it is the last microcontroller is set to 1. In this case, the remaining is 1, this one only. We are forcibly moving to 0, making it constantly 0, and then we'll initiate the transfer. That's what clock stretching.
What do you mean by making the master 0? Like which signal are we making 0?
Signal in the sense we have the clock stretch signal, like whenever the clock stretch is enabled, it just go to 0, like that we need to write. Clock stretch enable is means what we need that delay between two clocks. So in that case we just put as a 0 by using conditional operator. Also we write whenever the clock stretch is not enabled, just normal clock is equal to normal clock. Suppose the clock stretch is enable is high, then 0 is assigned to the clock, or else normal clock only. No need to be 0 or 1. Suppose normal clock is moving like this. Whenever clock stretch is enabled, then it should go to 0. In normal case, it should be as a normal clock only like this. Okay. So whenever clock enable is high, it will go to 0. Else clock is equal to normal clock. Clock is equal to clock. Like that we can write the condition.
Okay, so when clock stretching is enabled for one of the master out of the two, that depending on the value, the priority goes to that particular master.
Yes.
Okay.
Okay, clear
I
everything.
have one question. Like, suppose both the masters are sending one, but we know that only one will get communicate with the slave. The one which will the slave which will see the 0, that will lose its arbitration, right? So how it's going to means detect that?
Both masters in the sense, first of all, address will be calculated in terms of 0, 0, 0, 1, 1, 0, 1, 1, like this only, right? It will be counted in this direction only. So first it will be checking 0, 0, 0, 1, 1, 0, 1, 1. That too, all masters will not be in a all ones case. Before we will be having zeros case also. Okay. So first it will give the priority for 0. As we are using the pull down here, SDA must be low only. Here, 0, 0.
So when we have like
We will get as a 1 here. So if all masters transmit 1, no one will lose the arbitration actually. They all will stay in the race. Okay, because SDA is getting 1. Okay, so arbitration will only occur whenever the master is 1 and output is read 0, which indicates like someone sending 0. So in that case only it will lose the bus. Okay, if all are in 1, all will be in a race, like all will win the bus. Okay, again after that it will be checking the keep on arbitration will be continued bit by bit. One will send the 1 and other will send the 0. Whatever 1 is sent, it is for 0. Okay, and it will get the back off. So it keep on it keep on will be in a race only because SDA is still 1. So it will be
Ma'am, the
checking one by one in the same, just keep on running.
ma'am, the example you shown M1, M2, where
Here,
yes, ma'am. Yes, ma'am. This one.
here in this case, all the masters 1 means there will be no mismatch. If there is no mismatch, all masters will continue to the next bit. Here we did
Ma'am,
right. All masters are 1. Here all masters are 1 in the sense output is 1. It is continuing to the next bit. All zeros. Again it continuing to next. All ones. It continuing to next. Like that until we get 0, 1, 0, 1. It will be in a continuing stage only.
the master with 0, ma'am, win the bus.
0, 1. Master 1 is a 0. Master 2 is 1. 0 into 1, 0. SDA signal will get 0. So this 0 will win. master 2 is a 1, so it will not win the bus. Master 1 will win the bus. Through the master 1 we will send the data. See here, you will get the clarity. Suppose here SDA signal is connected to the master. Okay, master 1 suppose, and master 2 suppose, and this SDA is connected to the pull down resistors. We need to use a low. Okay, so here master 1 is 1, master 2 is 0. 1 into 0, output is 0. This output is nothing but SDA signal. SDA is low. Always SDA must be low. Okay. So whatever the low here 0 is there, whichever master having 0, that master will run the bus and it can transmit the data here. But this 1 is there, right? This whatever the master having 1, it will be in hold. It doesn't transfer anything. It will be in hold, and it will be in a competition in next cycle. Next cycle, whatever the masters are there, it will be compete with that master. Until it gets 0, it will be in a competition only with the masters.
Ma'am, please explain with the waveform.
Waveform here,
Yes.
this waveform.
Yes, yes.
Okay, wait. having address 1 0 0 1 0 1. Okay, this master also having address 1 0 0 1 0 0, and third master is there. Suppose another microcontroller is there, again 1 0 1 0 1 1. Okay, now three masters are in race. Okay, here first we will write the arbitration for these bits started from here. Okay, and operation between these three, that output will be stored in the SDA signal. This is what SDA signal, right? So SDA is a 1. Whenever SDA is 1, we don't get the output because it should not be high, right? It should be low only. Pull down resistor, it should be low only. So these three masters will not won the bus. These three masters are in race only. Okay, no one got the bus. Now it is checking for next address and operation 0 into 0 into 0. So SDA is a 0. SDA is 0. Okay, now 3 will get the bus. Okay, but we need to select only one. Only one can won the bus and can transfer the data. Okay, so move to the next one. Again 3 are in race, but only one can achieve, right? So again move to the next one. 1 into 0 into 0. Output is 0. Okay, so now this M3 will lose the bus. Will lose the bus. M1, M2, both are zeros. These two will win the bus. Okay, these two. So these two are in competition now. These two are won the bus. These two can transfer the data. But in these two, we need to check the competition. Only one master can win the bus. Okay. So now again check. Already this one lose the bus. Here it won't get. Already it lost. Okay. Now the competition is only these two microcontroller, master 1, master 2. So master 1, master 2 is 1 into 1. 1 into 1 means 1. SDA must not be 1. So these two didn't got the bus. Okay. Again, go to the next. It will be keep on checking like this. 0 into 0. Okay. Output is 0. Now both will won the bus, but only priority is 1. Okay. So again, it will move to the next. 1 into 0. 1 into 0 is a 0. Now this 1, whatever the 1 is there, master 1 will lose the bus, and whatever the 0 is there, master 2 will win the bus, and master 2 can transfer the data now only at this point of time. Again arbitration will be selected, again masters will be selected. It keep on rotating. Okay, did you understood now?
Yeah, Prasanti, but how this series of bits will be get generated
Address,
from the masters?
we are
Okay,
writing
these
the address, right? Slave address.
slave
That's
address or
the
master
address
address?
directly. Hmm?
So,
Master
Slave
ma'am,
address.
These are to select the slave address. Okay, master at the micro, whatever the master's address are there, those.
hello.
Yeah, tell.
Yeah. So here, right? If I have slaves, 2 slaves are there or 4 slaves are there, the master will be sending the slave address. If that slave address matches, then the master will start to send the data. Correct. That is how the SDA will work. Now the arbitration why we are pointing out, right? If you have multiple masters, who will get access to the SDA line? Correct.
Mm.
Okay. Now, see, the master side, do we have any other address? So, whatever you are mentioning, it's 7-bit, it is related to slave address, correct? So, slave side, that arbitration is fine. Which slave needs to be accessed, we can check from that end. But this arbitration, now you are saying it like this, if two masters wants to access the same slave, obviously from the both the masters, the same slave address will be coming, correct? There will be always a competition between the two masters, correct? So what the priority will be with respect to what, or there won't be any priority, it will take one of the masters because both address will be same, correct, from the master's point of view, correct?
Okay. See here, first of all, not master address. I also confused. First of all, not master address. It's a slave address only.
So slave
Whatever.
address should be same, correct? If I have access to get both say in the picture you are just showing in the slide, the microcontroller in the up on the two microcontroller will be wanted to access the gyrometer. Both will be sending the same address, say 100 101, correct? So there will be a competition between two masters because there is no other bit in order to specify which master. So both will be in a race to which your AND operation you are mentioning.
Both will not be same. See, whatever. Okay, let me show it. Suppose a 4-bit, if we think 4-bit means how many slaves we can connect? 16 slaves can connect, right?
Yes, 2 raised to 4.
If we consider here, suppose 8 to 15, I'm considering just one example. Even with 8-bit also same. Our actual size is 8-bit data. Suppose if I consider 4-bit data, these are last 4 bits. Okay. Anyway, if you take from 0, here we will get all zeros. Okay. Now, okay, let me take from that only. Suppose these many slaves we have, 15 number of slaves we have. Okay. Now, one master will get master's addresses will be there for all masters. So these all are slave addresses. Okay. So how the master will be selected? Suppose master 1 can be connected to two number of slaves. So 4-bit size data will be having. So these all masters are generated with the slaves for all the slaves. Okay. So master, uh, suppose if you think there are 15 or 16 number of masters, it will be checking 0 into 1. Okay, so output will be 0 obviously. So all these masters will lose the bus. Now all these at first attempt, all the masters will lose the bus. Okay, so whatever zeros are there, this 0 will won the bus. Okay, again all these zeros will come to competition and checking with the second one. So now these 4 zeros, these 4 ones, 0 into 1, 0. So these 4 zeros will won the bus. Now again the competition will be these 4. So here these 4 will be checking and these 2 will won the bus and these ones, these will lose the bus here and these will lose the bus here. Okay, and finally these two will come into the competition and next stage 0 1. When we check with the 0 1, this will lose the bus and 0 will get. So finally to this slave address will be selected and the master address will be selected in the same way. Both are same. Right side master's, read side slave address we need to select, right? So like this, the master one will be selected and will get the bus. And in second, this master is completed. This master already did it task. So it will this master task will be completed. Now remaining these all masters come into the race. Next, this master will run the bus, and then it will complete. It will go completed its task and go out of the race. And next competition will be this, and next competition will be this. Like that, one by one will achieve the transaction.
Okay.
And the
Understand?
master with the address 0 and will prioritize every time.
Every time prioritize means if it is there uh, in the circuit, it will get the first priority only. Once its task is completed, it is just removing, right? Its task is completed. Then next masters will get the transfer, will run the bus.
Yes.
Ma'am, hello.
Yeah, tell.
So overall, if we have two masters in I2c overall circuit diagram, with adding an extra bit along with the slave address, I can do the arbitration between two masters,
You
correct?
can write.
04.
Yes.
Okay. Okay.
Master never send their own addresses. It
Yes,
will
yes.
be having slave address. Just to
Also, we are
communicate this
adding an extra bit for the arbitration logic between the masters. Okay. Okay. Thank you, ma'am.
others. Any doubts?
So in this scenario, like we have slave addresses from 0 to 15, right?
Hmm.
How many masters do we have?
Masters can be any master like
There are n
what
number of masters. So when
number
there
of
are n number of
masters.
masters, they are competing with the 16 slaves, and based
Yes.
on the and operation that you said, the
Hmm.
zeroth slave will be prioritized.
Yes. Suppose
What
uh,
if we just have
suppose
one slave?
wait, I'm telling. Suppose we can't tell every time all these slaves will be connected. Every time 15 number of slaves will not connect. Maybe sixth slave is connected, ninth slave is connected, 13th slave connected. Three slaves are active. Remaining slaves are not active. Okay. And there are three number of masters. Master 1, master 2, master 3. We will keep these slave addresses to the three masters. Okay, so master 1 address is this, and master 2 address is this, and master 3 address is this. What 0 double 1 0 and 1 double 0 1 double 1 0. Now which master can send the data to the slave? That is what arbitration. There are three maybe one master also will be there. Based on the slave, where one master also can transfer the data to the three number of slaves. Okay, suppose if there are three number of masters and if the address is in this direction, then first it will be checking with this 0 into 1 0. So this master 1 will won the bus and remaining 2 will loss. From first bit only we got which master can send the data. So this master 1 will send the data to three the masters in first transaction. Maybe you may get the doubt like what about master 2, master 3? They also need to send the data, right? In the second transaction, the race between master 2 and master 3. Now see here 0 0. Both will not having in 0 1. Okay. Now master 3 will lose the bus and master 2 will get the bus. Now master 2 can communicate with these all slaves. And then master 3 will communicate with the all slaves. Simple example. Suppose if you see here, yesterday I told you the same example with the washing machine. In washing machine, suppose this is a wash task and this is drying purpose. Okay. This washing whatever the circuit microcontroller is there, it should communicate with all the sensors and circuit, right? Except related to the dryer. Even dryer sensors also it need to connect. Every controller need to connect all its own circuit. So according to the slave addresses which are going to respond to this master, the master will run the bus and it will communicate with all the slaves and it do its task, it complete its task, washing task first, and it will aside. And now this second master will run the bus and it start communicating with all the slave and it start doing its own operation, dry operation. So one after another. That's what arbitration concept. Clear?
Yeah, so in the previous example that you showed with like three
Another
slaves,
thing is
M1, M2, and M3.
master. Just 1 second. Another thing is which master need to select. Slave side slaves are selecting the masters, right? As suppose same example, if you take washing machine, as a user, sir, if you are user, you will be selecting first, you will giving the options wash or dry. In wash also you will be giving some options of quick wash or slow wash, like that there are multiple options. So we are giving the inputs at a user side, and also the microcontroller will get the inputs from slave side also. So total system will work in that direction. The inputs will be sent to the microcontroller. Based on that it will be communicated. Yeah, tell. What's your doubt?
Yeah, in the previous example, we saw like three masters, right? M1, M2, and M3.
Okay.
Can we go back to that slide? Uh, the one with numbers.
This one, no?
No, the priority one that you showed, like with 8 bits.
Here.
Yeah. Yeah, so here you showed like three masters, and we have like three slaves. They are competing with like to access three slaves. Now, what if we have three masters, M1, M2, and M3, and we just have one slave, that is 0, 1, 1, 0. So, how is that? Which master will get access to that one slave?
First it will be okay, suppose this
Yeah,
only
no, it
master
is.
is there, it will be checking the SDA signal again. Whenever the 0 is there here, it will run the bus and it will get it will start communication.
Okay, it's just comparing that one bit, like it doesn't have anything to compare. Okay,
No,
got it.
just 0 bit. It must
Okay,
have 0. That's it.
okay.
Yeah, tell remaining.
Ma'am, I have one doubt. This you're saying this case now where you have three masters, they are trying to access one slave, but that will not be possible, right? Only one master can at a time access one slave, right? Not three masters, right? Can access one slave.
That only we are doing, right? Only one master can access one slave. Here we are not transferring the data from three masters. Finally, only one master will get the access. Only one master will transfer the data.
Do we have a separate arbitration for the master also, like how the slave is also there? Is there something
We
to
are not
select which?
doing arbitration for slave. We are doing for master. By using slave addresses, we are doing for master. Addresses will be same for write or read. Based on the write or read bit, we will select the direction. Address will be same. See the format, frame format here. Address will be same for write or read. But here whatever the read or write operation is there, it will decide whether to write the data or read the data. That means to send master to slave or slave to master.
Now suppose there is a case that like three masters want to access only one slave, then how do you decide it? Like that is what my question is. You want to only access one resource, like
Three
So,
masters.
they want to access one slave only, one slave address only.
Okay.
How do we decide then that which master is going to access or where?
no,
Three, three masters, one slave, in the sense three masters having its address, right? Whatever the slave address.
Yeah, three masters want to access the same resource, a slave address, like this one only 0110, not all want to access the same slave address.
yeah, may
Then
I
all
interrupt?
masters will get that same slave address 0 1 0 1 0 0 1 1 0. So finally, okay. Yeah. Any other answers for this question?
Yeah, ma'am, that's what the same discussion I had with you, correct? Because we only require one address. On the top of that address, overall I2c subsystem outside the address you are giving to the processor, or that can, if you add an extra bit, if you have two slaves, you can add one bit. If you have four masters, you can add 2 bits. If you have more than if more than 4 means to 8, it will be like a 4 bit like that. It's like a location identification, that kind of bit. If you add, we can select a particular master. From the master, the address will be same, correct? So only address manipulation will be sufficient for the arbitration, correct?
Hmm. Um,
Means consider if I have a M1, M2, M3. So I need 2 bits. Along with this 7-bit address, if I add at the MSB 2 more bits, 00, 01, 10. That from that 2 bit you can select the particular master, and from that we can select the particular whichever address we got from the top or the processor. It will be obviously like that only. From whatever arbitration you have mentioned, we can do from that address. Only like we need one more extra bit to select the master.
um, by using or W, we select the master. We add that bit also to the master,
Ah,
and we
ah,
do the operation.
yes. Means if you need only 7 bit to select a particular slave from the processor end, whatever address you are getting, or in between we can manipulate one more bit such a way that which slave should be selected. If it is coming as 0, that M1 will be selected. If 00, M1 master will be selected. It is 01 in the sense M2 will be selected. 10 M3, 11 M4. Like 2 bit extra for the four masters, like that.
Yes. So here we can add the extra bit read or write
And
based
then
on
must
read or write MSB. If it is a 1, based on that next orbit will be selected. For these two also, we will add the read or write. So
yes,
based on that, any one master will be selected.
yes.
That's what he's telling. Yeah, we can do that also. Okay, now clear?
Yes, ma'am. Yeah.
Ma'am, please tell me again the last one. This we will add. How can we add for read and write? You tell that one.
Huh? Okay.
No. So if you have only one master and multiple slaves are there, whatever ma'am said is correct. We can use this AND operation to select a particular slave, on which slave should be selected on the address basis. So if you have multiple masters, right, we have to choose between two masters. So how we will choose between two masters which is accessing a common slave? So we need some extra logic or extra bit in order to identify which master need to be selected. If it is a 00, M1 master will be selected. If it is 01, second master will be selected. The address will be
Till
same. We
here,
need to extend the,
till here address is same. Two masters are accessing one slave. Okay, till here both addresses are same. he is telling like a write read. Write read means suppose it is a one read operation. If it is a zero, it's write operation, right? Suppose if we put 0 1 here, write read data extra for suppose this master as a 0 or this master as a 1, like that if we put, obviously this master will lose the bus and this master will win the bus. So through this master we can do the write operation, and through the master we can do the read operation, like that. Extra bit we need to add whenever we are accessing one slave.
Ma'am, if both master tries to read or both master tries to write, then
Read or write in the sense only one with that master we can do one write and another master read only.
Means we only have one lane, correct? At a time, either we can only one lane is there, right? Both masters cannot access at a same time. That's why we are doing arbitration, correct? Only one lane is there. At a time, only one can access. So who can access that? We are trying with the priority basis. How we are doing the priority? It is based on the weight of the particular bit. So LSB to MSB, the priority will decrease. If if it is the LSB bit is 0, that have more priority. It's come like that. The weight wise, the arbitration is done. Correct, ma'am?
Like
what you
that
are
also.
telling.
The lanes will be same for master 1 and master 2. Both can be done not simultaneously, one after another. It's half duplex. Okay. So I think everyone got clarity. So what is meant by arbitration and how the multiple masters can be selected. Now what is meant by clock stretching?
Two or more than two master never tries to
Hmm.
simultaneously read or write, no?
No. Suppose we have two masters. Okay. Not regarding the master cities. One master, one slave only. One master, one slave. Uh, we need to do the clock stretching. That means one master is working at a very high speed and slave is working at a low speed. Okay, if both speeds are not matched, there will be a data loss, right? So for that purpose, we need to make the master pass, just to pass some time. So slave can access the data. Normally in UBM, if anyone know, or FIFO memory will be there, FIFO. So what is the use of FIFO? Like between two components, suppose this component is working at very high speed and this component is working at very low speed, a transmitter and a receiver is there. Okay, so receiver is working very slow, transmitter is sending data very fast. Suppose in 10 nanoseconds it is transmitting 5 different transactions, but receiver side, for each 10 nanoseconds only one transaction it can complete. So in next 20 seconds, 20 nanoseconds, it is sending 10 transactions, but at 20 nanoseconds at receiver side it can do only second transaction. So whatever remaining transaction at final stage, the receiver will lose all the data, right? So for that purpose we are using some temporary storage component here, like it's a mailbox or any FIFO memory. We will store the data temporarily here. All 20 transactions will put the data here and receiver will access one by one. For every 10 nanoseconds, one, for next 20, next second one, next 30 seconds, third one, like that, one by one it will be accessing here. Okay, so that without data loss we are making both in a constant frequency, constant speed. In the same way, here clock stretching is nothing but when the slave device hold the serial clock. So this is what the serial clock low, the master need to pass. Okay, so it needs the more time to process the data. Okay, when suppose here in this example, if you see here, slaves are slow, like EPROM or sensors. These slaves are slow. Microcontrollers works at a very fast, right? So they can't keep both same speed, right? So for that purpose, here at master side, microcontroller side, we are stretching the clock. Stretching the clock in the sense, pulling the clock to low. SCL is forcibly pulling to low. Okay, that means we are waiting the master to wait state, forcing the master to wait state. So here like this, we are forcibly stretching to 0. So master will wait for some time. Meanwhile, the slave will complete its task slowly. Master cannot initiate next instruction fastly. Okay. So how it will work in the sense, first of all, master will initiate the communication here. Okay. Start plus address. Slave will get the acknowledgement address. Again, master will send and read the data. Slave will wait. Wait, I am not ready. Slave will tell like that. Okay. So, slave will pull SCL low. Master, whatever the master want to send the data next bit, but it can't. Why? Because SCL is low here. Okay. Whenever master want to send the next bit again, it cannot do. SCL in a low. Okay. So whenever slave finishes the process, slave release the SCL signal to high. Here it is a low. It's still doing some process. It is keeping clock in a low. Whenever it completed doing task, again it will you run high. So whenever it is high, master will initiate the transfers again. Again, whenever slave is not able to get the transactions, more number of transactions at a time, again it will make the clock as a 0. It just forcibly making the clock as a 0. In that time, slave will complete its task. It completes its read operation. Okay, that's what it means clock stretching. Slave will release and force, release, force, like that. Masters send the transaction, resume the transaction. That's what it means. Clear?
No, no. So how the clock is get so I have somewhere from the clock generation module I'm getting the clock for that EEPROM or some sensor I'll be getting the clock. Now we are stretching in the clock means we are forcing it is in the circuit means the waveform we can see this steep clock will be stopped like that. Is it possible to stop clock like that, or it is like an
Not
internal signal?
stopping. We will just put for some time in a 0. Whenever the stretch is required, stretch is enabled. We write the logic like whenever stretch is enabled, clock is equal to 0. Just making clock is equal to 0 for some time. Slave will stretch the clock. Master will not stretch the clock. Master just won the clock. Slave will make it as a 0. In that time, slave is complete its task. It transfer its data. Again, slave will make it as a 1.
Oh,
So
so
again,
clock
master
is
will
clock.
initiate transfer.
So here clock is just like any other input. We can manipulate the
Ah,
clock inside
yes,
this slave.
signal. Yes.
Okay.
Suppose what if master ignores the clock stretching? What if master ignores the clock stretching?
It will start sending the data when the slave is not yet ready. The data which we send to the slave, it may got corrupt. It will get corrupt.
Okay. So if master ignores the clock stretching, simply master will work at a too fast and it ignore the clock stretch. maybe in that case we will get the miscorrupted data, or the communication will be failed, or that's how. But good masters, like whenever we write the program properly, the master drivers will support the clock stretching definitely. Okay, clear? I2c protocol, everyone. These are mostly important concepts in interview point of view. Clock stretching and arbitration. Any other doubts?
Clock stretching is done by slave, not master, no?
Yes, not master,
Only done by slave.
slave. Yes.
Okay. When it processing the previous uh, instruction, it hold the clock.
Yes.
When it
Because
completed,
slave only know that, know, right? When it want to be slow, master will be always seeing to send the data only, but slave only know whether it can receive the data or not. Whenever it needs some time uh, to wait for master to keep constant at master side, then it will put clock as a 0. It forcefully stretch to 0. Otherwise, whenever it is ready to accept the data, it can make clock as a high. Okay.
How many, is there any limit or any boundary such like that? How many clock cycles the slave can stretch? Or
Uh, it's not like that every transfer it can do. For every transfer, mostly 8 bit of data, 10 bit of data will get, right. So bit by bit it need to transfer. In that case, it can do for every transfer or number of transactions.
means this stretching can be after sending the slave address, also can be after sending the slave data, means this data. Both side it can be happen. Correct.
Yes, read side.
Only thing like this, the acknowledgement is getting delayed. That is how the master will identify there is a stretching at the slave side. Correct.
Yes. Okay, girls, any doubts? Have you tried RTL coding? Hmm? I forgot to explain tool access, right? In weekdays, one day we'll have a session on tool access, how to install the Quest Async. Okay, so everyone know how to write the system Verilog test bench? Even if you don't know, try to
Yes.
understand over like a top level how we can connect a normal batch, regular batch we have completed till oops concept, right? Even you also can understand top level how it is connecting. So first we will go with the design, I2c design. So here design will be the slave. Yesterday we have seen the circuit, I mean the states, number of states and what will be done in each state, right? You can open that and check parallelly. Okay, so slave will be the design, master will be the initiator, test bench. Okay, so here we are connecting the system verilog test bench as a master and design as a slave. Okay, so see here module I2c slave, input reset, clock, SDA, data, data out and address out. Inputs and outputs are declared here. Next, wire, write or read. Write, if it is a 0, it's write operation. If it is a 0, it's a read operation. And input address, temporary data, write data, read data, CPO and parallel in serial out, PSO. Yesterday we discussed, right, what is the need of serial in parallel out and parallel in serial out. And count is required for every circuit to count the number of clock cycles, because whatever 8-bit address or 8-bit data, whatever we are sending, it can be checked with the counter only. And present state, next state, serial SDA out, and direction enable. Direction enable in the sense read or write direction, it will be checking by directional enable. And we are creating the memory memory is just to store the data by using the memory only. In protocol we need to store the data, right? And remaining all are enable signals. Why do we use the enable? Whenever you want to do the write operation, you should have some control, right? Whenever the write enable is high, then we can do the write operation. Whenever read enable is high, we can do the read operation. Like that start to stop also control signals. Whenever count enable is high, it will count from 0 to 7 or 0 to 8, like that. Like serial in parallel out. Whenever CPO enable is high, we can do the shifting operation. Whenever PSO enable is high, we can do the parallel in serial out operation. And CPO valid just to check whether the data is valid or not, and stop enable, start enable. These all are different temporary signals. Okay, you may get that out, like how can we remember all the signals? You can write your own signals also. Okay, so whatever the comfortable, like according to your program, whatever the signals requirement is there, you can write only those signals and check the output. Okay, next, parameter. There are n number of states: ideal, start, register address, acknowledgement, write acknowledgement, read acknowledgement, stop and wait, stop wait. And here directional enable is just checking for SDA. SDA is equal to, whenever directional enable is high, the output will be sent to the SDA. SDA out is sent to the SDA, or else JET, high brain state. Next, main data out. To the data out actual variable, we are assigning read data, and assign address out, comma write address. Total 8-bit address, storing to the address out, 6-bit, total 7-bit, right? 0 to 7. So 6-bit will be the address. Next bit will be the read or write. 0 to 7, 7-bit will be the address, 8-bit will be the read or write. So this is how we can assign. And next, present state, next state logic, which is common for all finite state missions, and counter logic, just go through that. And write address, read data. So how we can do the write operation and read operation? Write operation is nothing but memory of address is equal to Write data, read operation is nothing but read output data is equal to mem of address. So that's how we can do write and read operation. And next start condition I already explained yesterday. Whenever negate SDA because high to low, SDA must be high to low, right? Here. So negate here. Whenever the clock enable is high, the clock is constantly high, and start enable is high, it go to the start state, and always at the rate of pausage SDA. SCL must be constantly high. Pausage SDA means high to low. High to low is a stop condition, and stop enable is high, then stop equal to 0. And next main FSM. So currently in ideal state. So if it is in ideal state, what is the next state? Start state. Else next state will be the ideal state. Open that. Yesterday I have shared, right, the notes for i2c. Open that and parallelly check. We are in ideal state. Next state will be the start state, and present state is in start state. The next state will be the register address state. Present state is in register address state. If count is up to 0 to 7, then we keep on storing the data. Next state will be the register address only. Here we are writing only what is the present state, what is the next state. We are not writing the output. Output is separate, and the logic is separate. Else next state equal to register address acknowledgement, and currently we are in register address acknowledgement. So we need to check if SDA out is equal to 0 and write read is equal to 0. So write operation. If it is a write operation, next state will be the write state. If it is a read operation, next state will be the read state. So same thing we are writing here. Else next state will be the stop state. If we got the NAC acknowledgement as a 0. If it is a 0, it will go to the write or read. If it is a 1, stop state, not acknowledgement. Then current state is in write state. If count is greater than or equal to 0 to 7, it will be in keep on write state only. Like a loop, it will be sending a 0 to 7 bit data. And else next step will be the write acknowledgement. So next state is write acknowledgement. If SDA out is equal to 0, then next state will be the register address, or else stop state. Read operation, read acknowledgement, stop wait. Stop wait in the sense we need to wait until we get the stop enable is high or stop is high, then only it will go to stop state. Or else it will, if it is a start condition, then it will be going to the start state and stop. So whenever start is high, next state will be the stop, or else stop state directly. Next, address present state. In ideal state, what are the enables? Must be high. Direction enable will be 0, SD out will be 0, count enable 0, PSO enable 0, CPO enable is 0, write enable 0, read enable 0, stop enable 0, start enable is high. Why? Because in ideal state, only whenever start enable is high, we do the start operation. Next, in next state, write enable or read enable must be high. Like that in every state, whenever the enables are high, automatically it do its own task. Because if you see up here, everything is or dependent on enables only, right? Whenever write enable is high, write data. Whenever read enable is high, read data. Like the start enable is high, start operation. Stop enable is high, stop operation. We need to know in which state we need to activate those enables. Okay. So in start state, nothing, all are 0. In address register address state, CPO, serial in parallel. Serial in parallel, count enable is high. Write data equal to 0, direction enable is high. not only these, see here, whatever the serial data we got, assigning to the address in, not only like this, just enable remaining signals also, and check what it will be happened if the enabled signals are high in particular states, and write state count enable is high to count the number of data clock cycles, and serial in parallel enable equal to 1, and acknowledgement direction enable is 0, and write enable is high in write, and in read enable is high, parallel in serial out is high, and count enable is high, acknowledgement. You can just check, and reset for SIPO, for serial in parallel out shift register logic, for parallel in serial out logic. So when we get the parallel serial in parallel out, whenever SIPO enable is high, data is equal to serial in parallel out. STA comma SIPO data of 7 count. Okay. And parallel in serial out, read data count equal to count plus 1. 1 by 1 bit data is assigning to output data serially. Okay. Not only these expressions, we have discussed a lot of expressions before, right? You can use any. Okay. So this is what I2C RTL design. Everyone understood? You need to practice this whole week. Just take time and practice. You will understand. Any doubts still here?
No.
Hmm? No?
Nothing for now.
Okay. Next, system Verilog test bench. How can we write here? Verilog test also included, but what are the inputs? Module I2C top, I2C slave, initialization, reset, input 67, right side,
Is,
right address 67,
is this
it's required. We will write,
is this
we'll,
self-checking test bench?
it's direct test bench. We'll see system Verilog test bench.
Means it will generate the data packets on its own, and it will read, and then it will
Huh?
show the result. Right? Is it like a self-checking test bench, right?
Mm. See system Verilog test bench. First, whenever you're writing SVTP, first of all, try to start from interface or transaction. Okay. So here, interface. What is the difference between interface and virtual interface?
Uh, like it's like because of static and dynamic condition, we cannot directly use this interface inside the class. So in that case, we use some virtual keyword.
Okay. Ranjit, what is the difference between interface and virtual interface? What is the difference between transaction and interface?
Ma'am, virtual interface in instance of physical interface, ma'am, which connect to duty and
Okay. Others, Roshini, what is the difference between interface and virtual interface?
And virtual interface is a pointer of interface, and interface we use to communicate between means test bench and DUT.
Okay. What is the difference between reg, wire, and logic data type? Shubham, Sweta. Why
In
do we
reg,
use logic in system Verilog? And where do we use?
uh,
Logic is used in the interface. It can be reg or wire. We will define it in the clocking block.
We define it in clocking block. Logic.
No, ma'am. We will define input or output in the clocking block.
Mm,
We will
okay.
define first all the variables in logic type.
Okay.
Then after that we can decide it.
Okay. Next question. What is the difference between generator, driver, monitor, and scoreboard? Wait, I will ask. Sunny, can you tell me what is the difference between generator, driver, monitor, and scoreboard? Jacob, Akash, what is
Generator is used for generating the transactions to the DUT for drive. The driver is for driving the transactions to the DUT. Monitor is for observing the signals from the DUT, and scoreboard is used for performing the comparison between the observed transactions and the expected transactions.
okay? What is the difference between mailbox and semaphore? What is the
Mailbox will
difference?
mailbox will generate constantly, means uh, uncountable number of packets it can keep in that mailbox. But in case of semaphore, we have to generate a number of keys. According to that number of keys only, that number of packets will be there in the semaphore.
What is the use of keys? Why do we need to use the keys?
to
It's
get
for like
to
for synchronizing mechanism, like yeah, for certain number of keys, that many number of tokens, that many number of packets will be permitted to proceed.
Okay. Without key, can't we use the semaphore?
Uh, that needs to check actually. Okay.
What is the difference between fork join all, fork join none, and fork join any?
ma'am in
Ma'am,
Ma'am, in folk join all, we all the processes start the parallelly, but once the all process stop completed, then only the other processes start outside the folk join. And in folk join any, all the processes start parallelly, but if any one process completed, then the outside the folk join other process will also start, while in fork join none, all processes start parallelly, but it will not wait till the process will complete, and the process outside the fork join will also start parallelly.
In fork join any, which process will start first and remaining which process will come out of the loop?
Ma'am, all the process will start parallelly according to the time unit. But if any one of the process will complete, then the process outside the fork join will also start.
Okay, fine. Next, what is the difference between transaction class and interface? how we send the transaction data to DUT. What is the pin level activity and what is the packet level activity? What is the difference between constraint and randomization?
Ma'am, constraint is a method of generating random variable, and randomization is the method of generating meaningful random variable. We have control on the generation of random variable by using different constraints method,
Okay.
randomization method, sorry.
What is the difference between illegal and not illegal? What is the difference between inline constraint and soft constraint?
Ma'am, if two constraints are similar, then soft constraint which we declare soft, the soft will, ma'am, have low priority.
Low priority?
Yes, ma'am, it will suppressed. The constraint defined with soft. If two constraints are similar when it applied.
Okay. Um, okay. What is meant by coverage and why do we need coverage in verification? Akash, Ashwini, Jacob, anyone answer? What is the use of coverage? Why do we need the coverage in verification? Yeah, tell.
To ensure if all the features are verified in a particular design.
Okay.
That is like functional coverage. And like if we have to check if all the RTL blocks are properly exercised in our environment, TB environment, that will be code coverage.
Okay.
Ma'am,
What
like
is the difference?
uh,
Yeah.
ma'am, we can't verify, and like we have 1500 like approx 1500 means array number. We can't verify each at a time, so we declare a group of like 1 200 200 to 300. We will group all the numbers in. We will get approx 7 to 8. We will give in the cover group and cross each of them to generate the random variable to get the bug in the duty.
Okay.
Coverage help
So
us to.
suppose there are 100 number of test cases.
Yes, ma'am.
Okay. For each test, we are writing some number of bins, and there are 1 lakh bins and 1 lakh holes. But still, all the test cases are passing. Okay. So whenever all the test cases are passed, we need to get 100% coverage, right? But still 100% coverage is not getting up. But test cases are passed. So what can we do in this case? What is the mistake or where we can improve the coverage report?
We should check if all the features are verified in the design. Like say, suppose we have like 5 features and 4 features are verified. We have test cases for the 4 features. All the test cases are passing, then we will definitely get 100% coverage. The fifth feature is not tested and we don't have test cases for the fifth feature. So we'll have to verify all the features for 100% coverage.
What do you mean by feature here?
Uh, in the design, like what and all are we verifying?
Okay, suppose we have 32-bit address. and also 64-bit size data. And some power on reset or any fuse signal, whatever. If you consider address and data only, these two are passing, but still coverage report is not getting 100%. So what can we do here? Suppose constraints, we have taken two constraints to generate the even values and odd values of address, and two constraints for data. So tests are passing, but still coverage is not okay. Suppose if coverage is getting 50% only, but these two tests are passing. Address is verified, data also verified, getting correctly. So what can we do in this case?
We should check if all the bins are getting hit. Like we will generate random values and we will group in the bins. So we can check if all of the bins are getting hit.
Okay, we can check all the bins are getting hit. Suppose here 32-bit size bins, 2 power 32 number of scenarios we need to check. Whenever 2 power 32 number of scenarios are hit, then only we will get the coverage report. But if in real time, if you see, there are lakhs of bins, lakhs of holes will be there like that. Every bin will be hit thousands of times, but still all tests are passed, but we don't get the 100% coverage in most of the cases. So what will be the problem we can see in that case?
Maybe corner cases not hit. Corner cases are
Corner
not
case
hit.
is also hitted.
Mhm.
Maybe there will be some bins externally connected from previous project to this project. So in that case, we can waive off the bins. Like the means we can waive off in the sense we can remove those bins which are unwanted bins are there. In most of the cases, we will find that in SOC level. If you go with SOC level, because there we will find lakhs of bins. So you can just do wave off and check the coverage report. Mostly 20 to 30% of coverage, functional coverage or even toggle coverage. In real time, we will have these two coverages, functional and toggle. All after weaving off, we will get lot of difference in coverage. Okay. So this is how we can check, we can extract and we can upload the coverage. Next question. What is the difference between dollar rose and dollar fell in assertions? Why do we write the assertions first?
Assertions are written to check if at a particular clock edge we have the value, like we
Ma'am,
are
dollar,
observing a particular value.
Okay.
So
ma'am,
dollar
dollar
rose,
rose
Dollar rose.
applied in the ma'am rising edge, and dollar fell is applied in the falling edge.
So
Let
dollar
me verify.
roses means if a signal has transition from zero to high, like low to high at a particular edge or something, and dollar fell is from high to low the signal transitions
Yes,
with
yes.
respect to the clock.
Okay. Dollar rose in the sense, okay, it return the true for cycle whenever expression goes to 0, 1, rising edge. Okay. And fell means 1 to 0, falling edge. Fine. What is the difference between immediate and concurrent assertion?
Immediate in the ma'am give result in the same clock,
Okay.
and
concurrent assertions can check the design behavior for multiple clock cycles.
Okay. Any example?
Like to check a particular signal occurring like 5 times continuously or non-continuously.
Concurrent assertions, will it run parallelly with the design or serially? Concurrent assertions. And also concurrent assertions are written within the procedural statements or outside? Immediate
Outside.
and concurrent. Immediate?
Immediate is placed inside the procedural block,
Okay.
but not concurrent.
Okay. Can you tell me real-time example for polymorphism concept? Real-time example for polymorphism.
Ma'am, Wi-Fi.
Wi-Fi? Polymorphism or encapsulation.
So ma'am, here also we use one-to-many, and without password nobody can access that Wi-Fi.
Okay.
Example of encapsulation can be like a bank account or our the property, land property.
Bank account, land property. What we do with that? Don't say stylish answers. Just complete what you are telling. Will you answer same with interview also, interviewer? What we do with encapsulation? What is the exact definition or the concept?
Ma'am, encapsulation is hiding the variable. We can't allow the child class to override the value.
Child class cannot override the value. Okay. How can we how can we use without overriding the value? How can we give the access to the
By
child?
ma'am, some function handle.
Function handle. Okay. What is that function handle?
Ma'am, it is declared inside the parent class. We have the access of the function, and through the function we can override. We can direct override or something.
How can we override the data in system Verilog in object-oriented programming?
Ma'am, in normal class, we create a handle of the parent class, and then we got the access of the variable, then we can override the values and create with the constructor new first.
What is the difference between virtual function, virtual class, and virtual task?
If the class is defined as virtual, it's an abstract class. We cannot directly instantiate that class. We'll have to create a child class for it and then create a instance of it. If the function or a task is virtual, we can override that particular uh, properties in the child class.
What is the difference between function and task? Virtual function and virtual task. most of the UVM task and functions we write as a virtual only, right? What is the difference?
Can we write task also as virtual?
Yes.
I think it's the same difference like between a function and a task.
Okay.
Like functions, we cannot add timing control statements. In task, we can add delays and timing statements.
We can't call task inside the function because it may contain some delay.
Okay. Task and function is okay, but why do we use virtual keyword for that? What is the difference between local and protected keyword in encapsulation?
Local is like the data or the properties will be accessible only within the class. In protected, we will have like it's accessible even to the child class.
Okay, fine. What is the difference between dynamic cast and normal static casting?
Ma'am, dynamic cast check whether it is if dynamic cast successful, then it will give one. We can check inside the if else condition.
What is mean by casting?
Casting means, ma'am, creating a
Changing
copy
the data
and
type.
Converting one data type to another data type.
Then what you are telling if else copying? It's not casting. Casting means converting one data type to another data type. In static casting, we use normal tick inter like that. In dynamic casting, we use
dollar
dollar.
cast.
Next, what is the difference between ignored bin and illegal bins? In coverage?
When we don't want to have certain bins to contribute to our coverage, we ignore them. That will be ignore bins. And some values that are illegal for the output, that we declare it as illegal bins.
Okay. Okay, fine. So almost concepts. What is the difference between mailbox and queue? Difference between mailbox and queue.
Mailbox, it's like a method where we connect the components. So we'll have try method, get method, like to put the transaction into the mailbox or get out of it. A queue is like a data type where you can uh, like put the data, like we use push and pop and try to get the data or push the data into that data type.
Why do we use mailbox between the generator, monitor, or driver? Why don't we use queue or arrays?
Ma'am, through mailbox we can provide blocking system.
Blocking?
Blocking mechanism we can provide with help of mailbox.
What is the difference between blocking and non-blocking?
Blocking is like the execution will happen one after the other. Non-blocking, it's parallel.
No, I'm asking in mailbox. What is maybe blocking and non-blocking? Can you explain what is the difference between dynamic memory and associative?
Ma'am, dynamic array we can initialize dynamically, and in associative,
Yeah. Dynamic array.
In dynamic array,
Wait,
we can
let
change.
him explain.
in dynamic array, we can change the size by overriding and its old arrays.
We can resize, not changing the size. We can resize.
Yeah.
Okay.
Yes, short time storage like a matrix. Once when we need whenever we need for a small storage purpose, then we use that. Otherwise, we can also resize it. It's also like a dynamic array, but here we use as a small purpose of like a storage.
Revise all the concepts once again this week. Okay. In the next week, we will start APB first. APB and the second session will be there. Also, variables are declared and clocking block mod port, just check it. And in transaction class, how the constraints are written. And we will start APB protocol. Okay. AMBA protocols. So I'll share you some. That's it.
Thank you, ma'am.
Thank you all.
Thank you.
Thank you, ma'am.
Thank you.
Thanks.